Right, it is day 12 in geometry, and we are at the last day of week 3. So just remember, next week, week 4, is the end of term 2A, the first half of geometry. Next week, looking ahead, we will be having a quiz over Unit 2, triangles. So today, we just want to run through all the things we've learned, make sure that we understand what is expected of you guys for that quiz next week. And of course, we'll talk more about that next week as well. But for now, we're going to look at the do now. And I gave you a worksheet with, looks like 15 questions total. The first 10 are mid-segment questions, and 11 through 15 are exterior angle questions. So I went ahead and did the first 2 problems up here and have them displayed for you on the board. So what we're going to do is start at number 3 and just run through a couple of these. Make sure we feel good about mid-segment. So starting with number 3, I have a triangle. And I have 2 different line segments on my triangle that are labeled with values. My first value is x plus 4. And my second value is for this longer segment, 4x minus 8. What do we know about these 2 line segments and their lengths? For example, I'm going to ask this in a different way. How is the pink line related to the green line? Yes, Kelsey.
Okay, so the pink line is doubled in the green.
Yes.
2 of those.
So this pink line, if I were to double it, it would be equal to the green line. I can fit 2 x plus 4s inside of 4x minus 8. So what that means is that 2 of these, 2 mid segments, is equal to 1 of the longer segments. So if I wanted to write that out in an equation, how could I do that? What could I write, Jessica?
You can do 2 times x plus 4 equals 4x minus 8.
Good. 2 times x plus 4 equals 4x minus 8. We are always going to take the shorter section, the mid-segment. We're going to always take that times 2 and set it equal to the longer side, 4x minus 8. And so now we have an equation, and we can solve this. So I'm going to draw a line through my equal sign, and we will begin solving this. And once we have that equation set up, go ahead, Jess. You were about to say what to do.
You distribute the 2 to the x and the 4.
Yes, the first thing we need to do is distribute the 2 into x and into 4. So 2 times x
2x.
is 2x.
2 times 4 is 8.
2 times 4 is 8.
Then you bring the rest of your problem down.
Bring the rest of the problem down. Good. So equals 4x minus 8.
Then to make it easier, I subtracted 2x from each side.
Yes. Okay. So now we want to combine any like terms. We have x's, and they're on opposite sides of the equal sign. So we do want to subtract the 2x from the one side, and then we want to do it on the other side as well. Okay, so we're subtracting 2x from both sides. I'll draw a line. And what happens here?
Your 2's cancel.
My 2x's cancel. I'll bring everything down. 8
Equals
equals
2x.
good. 2x
Minus 8.
minus 8.
And then it's add 8 on your side.
Yes, so now we want to get our terms without x's together. We've got 8's on both sides. We want to get rid of this minus 8. That mouse. So we'll add 8 to both sides.
Your 8's cancel.
Good.
Your 8 plus 8 is 16.
Mm-hmm.
And you bring down your equal to it.
Good. So 16 equals 2x.
Then you just divide by 2 on each side.
Yes, just divide by 2. Yes, x equals 60 divided by 2 is 8. So for number 3, 8 equals x or x equals 8. Very nice. Very nice. Okay. Any questions on this problem? Or does this make sense? It feels okay. Good. Good. Okay. We'll run through another one. Let's look at number 4. Now, we again have two values. One of them being 2x minus 12, and the other one being 2x minus 2. So, I want to solve for x, and I want to set up an equation. What will that equation be? Go ahead, Kelsey.
2 times 2x minus 12
Good.
equals 2x minus 2.
Good. So we're taking 2 times the midsegment, 2x minus 12. We always multiply the smaller one times 2. And that's equal to 2x minus 2. Every midsegment problem like this will always be set up the same way. Smaller length, multiply by 2, set it equal to the bigger length. And now that it's set up, where do we go from here?
You distribute your 2.
You distribute your 2. So 2 times 2x,
4x.
4x.
2 times negative 12 is
So 2 times negative 12 is negative 24. And we'll bring everything down. Equals 2x minus 2. Okay. So now I have a problem with x's on both sides and non-x's on both sides. I'm going to have to move some stuff around. What is a good idea for our next step?
subtract the 2x on each side.
Yeah, let's subtract that 2x from each side. Get them together. Minus 2x. Minus 2x. And those will cancel. My 2x's cross out. And what's 4x? Take away 2x.
2x.
2x. Good. Bring everything down. What comes down?
Your negative 24 equals negative 2.
Negative 24. And my negative 2. And of course, the equal sign. And now we have 2x minus 24 equals negative 2. So all my x's are on the same side, so that's good. Where would I go from here?
You add 24 and so
Awesome. Let's add 24 on each side. Get rid of it over here. And now I can bring down my 2x
equals 22.
equals, yes, negative 2 plus 24 is positive 22.
And you just divide by 2.
And you just divide by 2. And what's our answer?
Your x equals 11.
Yes, x equals 11. Go. That is number 4. Okay, I'll leave that one up for just a minute. Pause it. All right, so let's go ahead and turn the page and let's look. So for number 5, again, I've got 2 different segments that are labeled. I've got 2x minus 18 and I've got x minus 6. Which one is the midsegment? Yeah, 2x minus 18. That is my midsegment. And the midsegment, remember, that's the one we multiply times 2. So if I know that this is my midsegment, I know I'm going to multiply that by 2. What equation should I write?
2 times 2x minus 18 equals x minus 6.
2 times that 2x minus 18 equals
X minus 6.
x minus 6. Perfect.
Can you distribute
Good. Same steps. Once you've done it, you distribute
the big 4x
4x
36
minus 36
equals x minus 6.
equals x minus 6. I'll draw a little line.
And you subtract x on each side.
Okay. Yeah, so after we've distributed, the next thing I really always like to do, and you'll notice we've done it this way for the previous 2 problems, is I like to get my x's together first. So what you just said, Jess, is a great next step. We'll subtract the x to bring it to the other side and to get rid of it over there. So that cancels my x here.
It'd be 3x minus 36 equals negative 6.
Good. So now we have 4x minus x is 3x. Bring down minus 36 equals. Yes, this one is where I would probably see the most mistakes because that minus 6, don't just bring down the 6. It's minus 6 or negative 6. Bring that negative down.
Then you add 36 on each side.
Yes. So once we've brought that all down, I know that all my x's are together. I don't need to do anything with that right now. We're going to get rid of anything that's not x. We'll get rid of minus 36 and then plus 36. That cancels.
3x is equal to 30.
Good. We bring down 3x is equal to negative 6 plus 36 is, you're correct, positive 30. And then
Divide by
wait just
3.
a minute. I'm going to rewrite this where I have a little more room. I'm going to just rewrite the 3x equals 30.
You divide by 3.
Yeah, and then that's your last step. You'll divide by 3.
Equals positive 2.
Good. And then your x equals positive 10. Okay. There we go. So that was number 5. Now, what I'm going to do for the rest of these problems, in case anybody got further and just wants to check their work, I'm going to pull out my answer key and I will give you all of the answers that you should get. That way, if you got further, you can see if you got them right, or if you decide to do these later, you'll have an answer key to check your work with. So, we just got number 5 is x equals 10. For number 6, you will get x equals 7. And number 7, you should get x equals -7. Number 8, you should get x equals -12. Number 9, you should again get x equals -12. And number 10, you should get x equals 10. Okay. So that is for the second page there. Can I move this, or does anyone need to see any of this before I flip the page? Okay, I'm going to flip over to page 3. Now, we don't have mid-segments anymore. Now we're looking at problems where we're using the exterior angle theorem. So I'm going to write that up here. Exterior angle theorem. So, first, did anybody get to this page, or did anybody try any of these? You may not have known that. Okay, you did. Awesome. Some of you may not have realized that these were even on here because I didn't make a note about it specifically. So, even if you did or if you didn't, we're going to go over probably 2 of these just to see how we feel. So, with the exterior angle theorem, we need to know that when you have a triangle, I'm just going to kind of write out what that theorem is one more time. When you have a triangle where one side is extended, we know that this angle is equal to the 2 angles here added together. So if this was A, B, C, and D, we could say that A plus B equals D. We know which angles are A and B because they are the ones that are not touching the exterior angle. C is the one that is touching it. A and B will be further away. So for number 11, we have, instead of A, B, C, D, we have R, S, Q, and C, I guess. I guess C is that point right here. So if we're trying to think of this in terms of that right there, R, would this be like A, B, C, or D? That would be like my A. S, what would that be? Yeah, that'd be like B. And this angle that's not really labeled Q, that could be C. And then 150 would be D. So I want to use these 3 values, the question mark, 35 degrees, and 150 degrees. I want to use these in an equation. What equation could I write?
Well, your A has a question mark.
Okay, Kelsey, you go ahead. You started first.
R
R.
plus 35 equals 150.
Yes. Yes. R, which is like our A, plus our B is like 35 equals D. Our D is 150. So the two angles far away from the exterior add up to equal the exterior angle. And we're solving for that missing angle R. So what would I do?
Subtract 35 on each side.
Just subtract 35 on each side. And then you're done.
I did x plus 150 equals 180.
X plus 150 equals 180. Okay, so if you do that, then you have solved for angle C. And then you could still use that to help you find this question mark angle. You could.
What I did is I did that and then I plus 50. So x would equal 30, then it'd be 30 plus 35 plus x equals 180.
Yes, that is absolutely perfect. You can do it that way too. I'm going to write out the method that you used next so everybody can see what you're talking about. We'll finish this one first. So I'm going to bring down my R, bring down my equals, and what is 150 minus 35? 115? Did you get the same answer, Jaden?
What was it, 115?
Yeah.
Yeah, 30 and 115.
Perfect. Okay, so R equals 115. Now, I want to show you guys what Jaden did instead because he basically did the exterior angle theorem, but in a longer way that still works. Sometimes the longer way will make more sense. Even though it takes longer, it can make more sense. So what Jaden did is he saw, okay, my C right here, I know C and 150 add up to 180 because they make a straight line. Then he called that X. So he did X plus, I'll put an X there, X plus 150 equals 180. And then you said you subtracted 150 and got X equals 30. So this is another way to do it. X equals 30. So now I know that this angle is 30. We still don't know what that question mark angle R is. So tell us again, Jaden, what did you do after this?
30 plus 35, right?
Mhm.
Yeah, 30
Yes.
plus 35 plus x equals 180.
Good. So then he said, okay, this is 30 degrees. I know 35 degrees. I don't know the third angle, but I do know that the three angles in a triangle add up to 180. So we do 30 plus 35 plus x or R equals 180. And then from here, we've got like terms to combine. 30 and 35, yep, give us 65 plus x equals 180.
So you just subtract the 65.
Are we only solving for the one that has a question mark?
Yes.
Okay, I was solving for all the angles.
Oh, I gotcha. Yeah, so you just went the extra mile.
Yeah.
Got more practice in. So we just needed to solve the question mark angle. We do minus 65, and we still get x equals 115. Yes. So both ways will work. Angle R is 115. Any questions about number 11? This was like this. All right, I'm gonna leave that up for a minute. All right, let's look at number 12. Another one of these. So for number 12, I have angle C is 46 degrees, angle B is a question mark, and this angle A here is 94 degrees. Which one of these is my exterior angle? 94. This is my exterior angle. What is this angle equal to? B and C added together. I add these together, it equals 94. So knowing that, what equation could I write?
B plus 46 equals 94.
Good. B plus 46 equals 94. Okay. And these are really nice one-step equations. What do I do?
Subtract 46.
Subtract 46.
Your B is equal to 48.
B equals,
48.
is it? Oh, yes, you're right. B equals 48. I was thinking about this angle and I was like, 48 and 94 do not make 180.
Well, there you go.
Yeah.
Okay.
Okay. I swear, my brain is fried this week, guys. I'm sure you can relate. Okay, so for number 12, we got B equals 48. And let's do one more of these. Anybody still need 12? Still writing it? Or you write? Okay. All right, so let's look at number 13. Which angle is my exterior angle?
93 degrees.
93 degrees. This is my exterior angle. And what is it equal to?
U and B.
U and V added together. So, what equation should I write?
U plus 47 equals 93.
Yes, U plus V, or 47. So U plus 47 equals 93.
G subtract 47.
Yep, just subtract 47. Good.
Your U is equal to 46.
Beautiful. U equals 46. Very good. All right. So if you are wanting to try the last two on your own for some practice later on, I'm going to give you the answers for those so that you can make sure you're doing it right. Number 14, you should get V equals 75 degrees. And all of these should be degrees. I have not been writing that. Sorry, guys. And the last one, number 15, you should get that G right here equals 60 degrees. Okay. And we have completed the worksheet. Awesome, guys. Okay. Before we move past this, though, for either of these topics, is there anything that we are not feeling the most confident about or a little confused about, or do we feel really good about? Give me like thumbs up, thumbs down, thumb in the middle. Good. Yay, lots of thumbs up. Okay. Love it. Love it, love it.
Extra practice with worksheets, just being able to drill stuff.
Right.
That helps a lot.
So way to go.
Yeah.
Okay, so if nobody else needs to see this, I'm gonna move this to the side and we're gonna take some notes. Last call. Does anyone still need to see this? Alright, let's put this to the side and I'm gonna get out my notes, which are somewhere.
That's right.
Let me pause this and I'm gonna get my notebook. So I got my notebook and I am going to title this Geometry Unit 2 will be our day 12 notes. We should only have one page of notes today. Day 12. It's Thursday, October 23rd. Right. So we have one last thing to learn about. I said that yesterday and I forgot about this. So I apologize for misleading you. This is the last thing in Unit 2, finally. We're at the very end. For real this time. So our little subtitle below this will be Triangle Inequality Theorem. Triangle Inequality Theorem. And this triangle inequality theorem says that A plus B must be greater than C. What on earth does that mean? I'm going to give you some context. So in a triangle, whenever we're using this theorem, we are talking about side lengths. So I'm going to write that out. Side lengths. We're not talking about angles. And when we use A, B, and C to describe the lengths of sides of a triangle, C is always referring to the longest side. So C is the longest side. And A and B will always be the two shorter sides. So we use this theorem to help us decide if I was given 3 different lengths, like 3 segments, and I say, can I rearrange these segments in a way to make a triangle? Yes or no? We can use this little theorem here, this formula, to see if it can. I'm going to show you how we do that. So, for example, I'm gonna give you the directions that say could the three side lengths be a triangle? And we would have something like 12 inches, 5 inches, and 30 inches. What we want to do here is first decide what is my longest side. Out of these three numbers, which is the biggest? 30. So right away, 30 is the longest side. Then I'm going to take my two remaining sides, my shorter ones, 12 and 5, and let's add them together. So short. So I'm going to write 12 plus 5 is greater than 30. What is 12 plus 5?
17.
17 is greater than 30. And now we ask ourselves a question. Is 17 greater than 30?
No.
No. So your answer is no. These could not make a triangle because they have to be bigger. So because this is not true. The answer is no. This is how you could show your work. Your answer is no. Let's look at another example. Let's say I have 14.2 centimeters and 21.5 centimeters. And 1 centimeter. Which of these side lengths is my longest side?
31 centimeters.
31 centimeters. Okay. So, what should I do with my other lengths?
Add them together.
Let's add them together. 14.2 plus 21.5. That better be greater than 31. Let's see, what is 14.2 plus 21.5?
35.7.
35.7. So I'll bring everything down. 35.7 is greater than 31. 35.7 is greater than 31. Is this true?
Yeah.
Yes, this is true. So, could this be a triangle? Yes, it could be. It could be a triangle. So, our answer is yes. That's all you have to do. You add the short ones. If they're bigger than the longest one, it's a triangle. If they're not, then it's not a triangle.
Pretty straightforward.
Pretty straightforward. Now, in case this is one of those things where I think it helps to see this visually, because this can feel like, okay, I know how to do it, but like, why? Why is that?
Yeah.
Why is that a thing? I'm gonna leave that up, and I want to grab something to show you with. Got some popsicle sticks.
Oh boy.
No. Okay. So I am going to shift that up just a little bit so I can show you my demonstration. And here's some sticks. Let's see. That one shorter. Scissors. Okay, so I'm gonna cut. Oops. I'm gonna cut one popsicle stick, make it a little short. Okay. And then I'm gonna leave one a little longer. And that one. This. Okay. So these are my 3 side lengths. Which one's the biggest?
The red one.
The red one. So let's see if these 2 lengths added together are bigger than the longest length. Are they bigger?
Yeah.
They are. They're bigger. So the answer would be yes. And I can prove that because whenever I put them together, they do make a triangle. Now let me show you what happens when this is not true, when it's not bigger than the biggest side. What if these were my 3 side lengths? Red is still the biggest one, so I'm going to add the 2 smaller ones together. Are my 2 shorter sides bigger than my longest side?
No.
No. No matter how hard I try, I cannot make a triangle with that. I can close the angles. They'll never reach each other. They're too short. It has to be longer. It has to be longer. So it must be greater than the longest side. Another thing that we might see, though, this is important. Show you one more demonstration. Because what if we get numbers where when you add the 2 shorter sides, they're equal to the longest side? Let me try that. Okay, let me get this red one to be equal. About right there. Okay, so let's say I have 3 sides. Red is still my longest side. And when I add my shorter sides together, they are equal to my longest side. Well, they're not greater than, so the theorem says that it won't make a triangle. And I'll show you, when I try to put these together, it will be really close. But no matter what I do, no matter how much I try to tilt those down to make a triangle, those ends will never meet because they're exactly the same size. They'll end up making a straight line. So if it's equal, It's not a triangle. It won't work. I'll show you with numbers an example of that. What if my side lengths were 5 inches, 12 inches, and 7 inches? What's my biggest side, my longest side? 12. What are my two shorter sides?
5 and 7.
5 and 7. So what should I do?
Add the 5 and the 3.
We'll add the 5 and the 7. Bring down my 12, and it should be greater than 12. What is 5 plus 7?
Well,
It's 12. So 12 greater than 12. 12 is greater than 12. Is that true?
no, it's equal.
No, it's equal. 12 is not bigger than 12. 12 is equal to 12. So this is not true. Is this a triangle?
No.
No. No. This statement has to be true for the triangle to exist. Okay, so I'm going to give you guys a couple of sets of side lengths. I want you guys to try doing a couple on your own. And then that's really all we're doing today. We have our quiz next week and midterms. So we're going to take it a little bit easy on you as we complete the first half of this class. You guys are doing excellent. Absolutely wonderful. So I am going to write, I'll just pick this up and put it on. Oh, did you need it still? Okay, never mind. I'm going to grab a sticky note and give you a couple to try on your own. So tell me if these side lengths could be a triangle. Number 1 will be try these on your own. Set a little timer, and then we will check our answers. Pause that, leave that up for y'all to see, and then we'll go over them together to end our class. All right, guys, it has been 5 minutes, and we're going to look at these. Number 1, 33 inches, 65 inches, and 28 inches. What's the longest side? 65. And the other two, when we add them together, what do we get? 61. Is it greater than 65? No. So number 1, our answer is no, not a triangle. This is not true. Number 2, what's our longest side?
47.
47. And my other two sides,
Yeah.
they add together to equal 47. Okay, so 47 is greater than 47. Is this true?
It's equal.
It's equal. So is it also greater?
No, it's
No, right. So is this a triangle?
Yes.
Is it a triangle if they're equal? No, remember the only way we can say yes it is a triangle is if this end statement is true. 47 is greater than 47. Is that true? No, it's not true. It's equal. So the answer for number 2 would be no. This is not a triangle. The equal is tricky. We just have to remember it actually has to be a bigger number. It cannot be the same number.
Yeah.
Okay. So for number 3, what's my biggest side length, my longest side? 6. So my other two
8.
sides, 3 and 5, make 8. So can we say 8 is greater than 6?
Yes.
Yes. Is this a triangle?
Yeah.
Yes. Good. How'd we do? Good? Not so, are we confused about it? Are we're good? Yay. Yay. Okay, guys. That is the last thing in Unit 2. If you know that you're all caught up for this week, you're free to go. If you're not sure, please check in with me before you leave, and I'm happy to look for you and make sure. And of course, if there's anything I can help you with, you're welcome to stay.